So we are here today to talk about how you can use SQL parameters to leverage Carto to analyze and extract insight from the Citi Bike trips dataset in Manhattan. So let me 1 second share my screen and make sure that you can all see the screen. There you go. You should be able to now visualize the Carto builder. So Citi Bike trips rental or bike sharing system have significantly grown in popularity across the globe as an eco-friendly transportation option. They basically offer a bicycle to users on a short-term basis for a price or for free. And this data typically involves tracking the origin and the destination points of these individual bike trips taken by users. So we have two different locations here, right, that corresponds to the start and the end of the trips. In this screen, we have where the users are taking the trips, so this station as the origin, where in this side, we have where the trips are started. Sorry that they had it upside down. And if we can see the table as well, we can see that we have two different geometries that corresponds to both the origin and the destination. So what kind of analysis and insights can we get by analyzing Citi Bike trips data using SQL parameters in Carto? Well, there are many insights that you could get, but for this webinar, we are going to focus on three of them. First, we are going to look and identify the peak usage time that can aid in planning maintenance schedule and pricing structures. Then we are going to jump into spotting the most popular routes by looking at common origin and destination combinations. So this can help in planning the bike lane infrastructure or determine where to increase the number of available bikes. And finally, we are going to wrap up with analysis of the bike availability across Manhattan. So we are going to identify if more trips start at a particular station and that end there, so to analyze which station might have a high availability or might actually have a shortage of bikes, so that with this information, we can guide decisions about redistributing the bikes across the system. So let's move to my demo, where I will be focusing on these use cases on the different neighborhoods in Manhattan, so we can relate the different trends and patterns between different neighborhood combinations. So let me jump into my demo. So this is Carto Builder, and I'm accessing it from the editor mode. So here I have all the different layers, all the different sources, and also some widgets and parameters. But before we go and look into the details of this demo, I would like to introduce you to SQL parameters, so you have a better understanding of them before we jump into the details of this demo. So what are SQL parameters? So basically, SQL parameters are those placeholders that you can use within your SQL queries to allow the viewer users filter and analyze the data using a simple UI. So this means that you can create an interactive web map application that will allow others to obtain their own insights according to their specific needs. So you don't need to be creating a specific dashboard, but instead provide the control to those viewers, users. So let me show you how these SQL parameters can actually be added to the SQL sources. So in this specific SQL editor, as you can see, I have some specific placeholders that I type within brackets. So here I have a where statement where I have selected the trip period from and also the trip period to, that allow the user using this control UI to basically define the values that will be replaced by these parameters placeholders. The same for the start neighborhood of the trip and also the end neighborhood of the trips. So now that hopefully you have an understanding of what SQL parameters are and how editors or author of the maps can actually set them up, let's move to the viewer mode of this demo so that you can easily see how viewers can interact with this dashboard. Bear with me 1 second. And hopefully if I check now the display, yeah, you can see the viewer mode of this demo. We have two different layers represented here. We have the start of the trips that are colored blue. The darker the blue, it means that more trips are started from that specific location. The bigger the size of the points, again, the more trips that are started at that location. And the same for the end of the trips. The end of the trips are colored in different red palettes. And the same, the darker the red, the bigger the point size, the more trips that are ending in that specific station. And we have within this map, a part of the map itself, we have at the bottom side and also the left side some widgets that allows us to obtain different insights and metrics from the data that is displayed on the map. So we can have the total trips, we can also see the trips per hour, and this also allows us to filter and interact with the data itself. And then on this side, we have the parameters. So with these parameters, users can actually control the underlying data that is rendered on the map. So, for example, if we are looking to analyze the trial period for a different range, we can very easily, using the control UI, set this to visualize the whole month for the trips. As you can see, the data has been instantiated again. We have different values now for the total trips, as well as the visualization for the whole month of January. In the same way, users can actually interact with the start neighborhoods of these trips and the end neighborhoods of these trips. So, for example, if we now change this start of the neighborhood to Upper West Side, for example, and now let's change the end neighborhood to be Midtown, we can basically visualize the different trends between these neighborhood combinations. So let's take a look at the different widgets to understand the data. So we have almost 2,000 trips for this neighborhood combination. And within the trips per hour, we can get an overview of the different trends and patterns from these neighborhoods. It seems that there is a lower usage if we go through the calendar during the weekends. And also, there are peak time usage very early in the morning. So you can see that we have 6 a.m., 7 a.m., and so on. And this makes total sense because we have selected the start neighborhood to be a residential neighborhood like Upper West Side, whereas the Midtown neighborhood is actually more known for the commercial and business usage. So we could assume that the subscribers using our bike sharing system are actually commuters taking the bike to go to work early in the morning. So let's now try to find a different pattern. If we look at a complete different scenario, for example, let's find a neighborhood that is mostly known for the nightlife offerings, right? So there are lots of pubs, restaurants, and so on. And let's see if we can find something from this data. So let's go to Chinatown. And then for the end neighborhood, I'm going to select Lower East Side. So as you can see, there are neighborhoods that are quite close to each other. And actually, just by looking at these trips per hour, we can see a total different scenario. We cannot see a lower usage during the weekends. Actually, it's quite frequently used on a day-by-day basis. We have around 2,600 trips for this specific time period. So quite a lot of trips if we compare to the previous combination. And if we look at the start of those trips, that's where the interested patterns is exposed, right? We have trips that are started at 1 a.m., 2 a.m., and so on. So this makes total sense because we can see that the subscribers are actually using our bike system to actually commute to work, but also when going to the nightlife, right? When going to pubs, restaurants, and so on. And they are actually using the bikes quite late during the night. So let's now focus and jump into the second use case. Let's understand what are the most popular routes between these different neighborhoods combination. But for that, let me actually change the start neighborhood to be one a bit farther from Lower East Side. So we can maybe select West Village to have a view of the different routes. So I have added here a layer, which are the bike routes. How have I calculated these routes? Very simple, using Carto Workflows. So Carto Workflows is a tool that allows you to perform step-by-step geospatial analysis in a very easy interface. This is the workflow that I have created, and within there, I'm using the Create Routes components, where you can set up your start geometry, the end geometry, and also the type of transportation. I have used bicycle, but you can use many options such as trucks, taxi, bus, and so on. So just a quick glance. If you are interested in knowing more about Carto workflows, just ping me. But here we can actually see very easy what are the most popular routes. Indeed, these routes that are actually combining stations that are quite close to each other are the most popular routes. So this could allow us to maintain the infrastructure so that we are sure that actually the bike lines are okay for these users. And also we might want to consider taking a look at those routes that actually are concentrating a lower traffic. So this could maybe allows us to promote the usage of this bike transportation mode, or find if there are probably some routes that are not very bike friendly. Okay, so we have seen how we can use SQL parameters for both peak usage analysis and to understand which are the most popular routes. But let's jump now to the bike imbalances, which can help optimizing the current bike infrastructure to ensure that customer satisfaction is high. Because you never want to reach a station when going to work and you find no bike at all, neither not being able to return your bike once you hire them. I'm sure that many of you have suffered from it, and when you are in a rush, it's definitely not fun. So let me hide these specific layers and actually now focus on the whole Manhattan itself. Let me now hide the routes. There you go. For this one, I have two different layers. One showcasing the bike availability using point geometry when I'm very close to the map, so you can get insight for the specific station. And then if I zoom out from the map, you can see the aggregation using spatial indexes. This is really cool because you can actually aggregate points to quad bin, which is a type of spatial indexes, dynamically without using any SQL at all. And now let's see what we have done here. Basically, we have calculated the bike differences for each of the specific stations. So we have calculated the difference between the trips that they start and the trip that end for each of the stations. And we can clearly see two different patterns are showcased in the legend. We have those areas, those stations or areas that are colored as red, and they showcase possible shortage or limited availability. What this means is that more bike start the trip at that station than arrive. So in other words, more trips started than ending at that specific location, which could mean that the station might frequently run out of bike. In the other hand, we have high availability areas like this area around here. What this means is that more bike arrived to the station than left. In other words, more trips ended at that station that started, which could indicate that the station frequently has too many bikes and it's not possible to return it. So this view can be really helpful to balance bikes distribution between both areas, the area with high availability and the area with limited availability for the station. So that's everything from me today. I really hope that you found this webinar interesting, and I look forward to answer any question that you might have on the comments. Thank you so much for your time, and I really hope that you enjoy the rest of your day. Thank you.